Assalamu alaikum. My name is Sayyid Tayyab Farooq, and I, with my partners Ali Hassan Ahmed Khan and Minaj Ahmed, under the supervision of Sir Farhan Ahmed and Dr. Ali Ahmed at MERL UIT, have created an UIT edition RISC-V instruction set simulator for our BURAQ Core chip. It supports 3 extensions of RV32, which is I, M, and C. We have named it Oxygen. This is the landing page of our website. It is an open source website built using Python Django. So let's dive into it. This is the editor interface of our website. As you can see at the top of the page, there are 3 tabs: BURAQ I, BURAQ IM, and BURAQ IMC. BURAQ I only supports I extension. BURAQ IM supports instructions from both I and M. BURAQ IMC supports all of the 3 extensions, which is I, M, and C. It is an intelligent editor, which means that if the user writes an invalid instruction, it generates a red line under that instruction, indicating that there's something wrong with the instruction. And if you take your cursor over it, it will generate a message which shows the user what is wrong with the instruction. But even after this, if the user decides to start simulation, the simulator will generate an error showing user the error with the instruction and the line number in which the error has occurred. So let us now demonstrate how the simulator will work if each of the instruction is correct. As you can see, none of the instructions here shows any sign of any error. So let's just go and start simulation. Clicking on the start simulation button will direct you to the simulator page. At the top of the simulator page, you can see 5 buttons, which are run, step, previous, reset, and dump. Run will execute all of the instructions at once. Step will go over each instruction one by one. Previous will take you a step back. Reset will start the execution from the beginning. And dump will generate hex of the instruction, which can be used for verification purposes. At the top right corner of the page, there are 2 tabs: register and memory. Registers will show you the register specification, and memory will show you the memory specification. As you can see here, the instructions are loaded into the instruction memory, and we have a variety of display settings such as decimal, hex, unsigned, and ASCII. So if I select hex, the format will be converted to hex. And this part here is one of our unique functionalities that we provide in our simulator, which is that we demonstrate each of the instruction according to its instruction format. So for example, there's an I type instruction here. So this is its PC counter, basic code type, and if the instruction contains immediate 1, its immediate 1 value will be shown here. If it contains func7, which this instruction does not, but if it does, it will be shown here. Func6 and func4 are the instruction format of C-type instructions, so they will not be used in I-type. So as you can see, all of the instruction does not contain func6 and func4. If the instruction contains RS2, it will be shown here. RS1, func3, func2, RD, immediate 2, and opcode. Func2 is also part of the C extension. And so you can see that none of the instruction contains func2. So let's just go over the instruction one by one. So if I click over the step, the step button, it will execute the first instruction, and you can see that first instruction has been executed and the value has been saved in the register. So we can go over each instruction by using one by one by using step, and uh, and you can see that after each instruction has been executed, it's the value, if it stores a value in the register, the value has been stored. And we can use run also to execute all of the code at once, and you can see the code has been executed, and a, a message was generated in the tab in the bottom right corner indicating that error, indicating that the code has been successfully executed. You can use the reset function to start the execution from the beginning. So see here that all of the registers uh, are changed back to their original value, and the simulation has been started over. So when so if you run all of the instructions and then create dump and then press dump button, so here you can see the hex generated by the dump. Okay, so this is for I extension. Now let us go and see. So here is a